Assalamu alaikum sir, this is my presentation submission video. So my topic was degree of concurrency and pathland, its concepts and its example. So I have submitted the PowerPoint file. You can tally it while reviewing this video. So the first slide is of the parallel distributed computation slide. The next slide is of the title of the presentation, my name and my roll number. On the third slide we have the index which shows all the tasks which are covered in the further PPT. Coming on the first slide we have definition degree of concurrency, its definition and its subheadings. So degree of concurrency is the amount of tasks which can be executed simultaneously at the same time. And in that topic, that means that while doing parallel processing, we have seen that there can be tasks which can be easily easily execute at the same time in case they do not have task independency or not. The subheading of degree of concurrency is maximum degree of concurrency, in which the maximum degree of concurrency shows that the maximum amount of tasks which can be executed at the same time in the whole process. And average degree of concurrency is the average number of tasks which are executed throughout the whole process. Coming forward, on the next slide we have factors affecting concurrency. There are three factors which can affect concurrency. Number one, number of available processors. Like if we can execute 5 or 6 tasks but we only have four available processors, then it will not be possible for us to execute all the 5 or 6 tasks which we we were able to execute due to less number of processor. We cannot execute all the 6 at the same time. Secondly, they are nature of task, whether it is independent or dependent. And third is the system architectures and its limitation. So that was for concurrency. Now I will show you. Now I will present path length. The path length is the total number of sequential steps which are required to complete a task. We have subheadings like critical path length, and average degree of concurrency. So critical path is the longest directed path between any between the starting node and the finishing node. Like if we start a task by executing one or two of its tasks, then going down the tree until it is finished, that whole length is called the critical that whole path is called the critical path. And the critical path, and one more thing, that critical path include it is always the maximum amount of time that it takes. So which path have the maximum amount will be declared the critical path. And critical path length is the sum of weights of nodes along the critical, the sum of all the nodes and from starting to finish of the critical path will be the critical path length. We will discuss this further in the examples which I have prepared. And average degree of concurrency is the total amount of work divided by critical path length. So critical path length was the sum of the largest path, and it divides the whole work, like how the weights of all the nodes in our process. So we will get average degree of concurrency, which means how many tasks are concurrently solved during the whole process. There are also some factors affecting path length, such as algorithm complexity and dependency between tasks, as there was in the previous factor of concurrency, in which there was also the nature of task, whether it is dependent or independent. Now coming forward to our example section, the first example that I selected was from the class notes which you were explaining us. So the first example of is the query process tree. I hope you remember the query process tree, which contains of four tasks at the stand in the beginning, and then two tasks were dependent on the above four, and then the last task of the finished node are dependent on the middle two tasks. So according to the tree, we can see that the starting four tasks are concurrent because they can be easily executed at the same time. Then coming down, we so our maximum degree of concurrency will be 4, as 4 tasks are concurrently being solved at, and the total amount of work after summing all the weights of the nodes is 63, and the critical length path length will be the maximum weight path, in which it is the first path of node 10, node 4, task 4 node, task 6 node, and task 7 node, which have the weight 10, 9, and 8, which will be sum to 27. So 27 will be our critical path length. After that, we will find out the average degree of concurrency for this process, and the average will be the whole sum of whole process divided by critical path length, which will be 63 divided by 27, which will be answering in 2.33. So this was example 1. Now moving on to example 2. Example 2 I have selected from 2021 fast newses midterm examination. So this task also consists of seven tasks, each having different weight. So if you are watching the PPT, as you can see, there are the task is starting, the starting node is task A and going until the task G and task F. So we will first find out the critical path. After telling all the different paths and taking out their sum, the critical path will be 29 of task A, B, D, and G. The critical path length will be 29, and as we can see in the diagram, the maximum number of nodes that are being processed are 2. So 2 will be the maximum degree of concurrency. The total work, that means the sum of all the nodes, is equal to 42. So after finding out the sum, we can easily achieve average degree of concurrency, in which there is 42, which was the total sum, and 29, which is critical path length. So 42 divided by 29 will be 1.44, and this will be the average degree of concurrency for our example 2. And moving forward to example 3, which I have searched from the internet, as mostly the most common example was the one you teach us at the class. So there were not many examples provided there in tree form. So in this diagram, as we can see, the trees have different paths and node. So the maximum critical path we will get from this will be from the, it has basically, it had different paths, but first, if I see the picture, I will think that the critical path will be from the first node till the last node, which has weight 6. But as we can see, which we have also high weighted nodes like 11, which is going down to the 8 weighted node. So the critical path will be 33, which will be from the node having weight 10, 4, 11, and 8. And the maximum degree of concurrency, as we can see from the diagram in example 3, is 4, as there are 4 tasks concurrently being executed. The total amount of work done in this whole process is 67. The degree of concurrency will be 67, as it is the total amount of work done, and critical path length 33, resulting in average degree of concurrency of 2.03. So we have covered the definitions and example. Now moving on to the conclusion, we will conclude that both degree of concurrency means having the summary. The degree of concurrency measures the number of independent tasks that can run simultaneously, and path length we will uh, represent the total sequence of operation required to perform a task. There are applications in which it is mostly used in crucial distributed system, parallel computing, and algorithm optimization. So this was my presentation for today. I hope you liked it and will mark it for give good marks to me, as I have prepared it very well in my opinion. So thank you for your presence. The last slide is also a thank you. So thank you for attending my presentation.